Hi students, in this video we are going to discuss about the variation of pressure with the depth. But before that we are assuming that the fluid is either stationary or it is moving with a constant velocity. So here I have taken a fluid where the atmospheric pressure is P0 and the density of the fluid is rho, and the depth of element, because here I want to calculate the variation of pressure with the depth. So what I am doing, I am taking a very small element of the fluid and the depth of this element is y, right? Okay, and the thickness of this element is dy, and this cross section area over here, right? So that is a. Okay, so now we are going to derive the formula of the variation of pressure. So let's do it. So here see, this fluid element is stationary, right? So now if it is stationary, it means all the forces on this fluid element will be zero according to Newton's first law. Now we are going to take a equation for the vertical forces. Okay, so before that we need to draw all the forces on this fluid element. So see, here I am assuming the pressure on the top of this is P, okay, and at the below of this fluid element is P plus dP. Okay, I am just assuming it has increased something. Okay, so P plus dP I am assuming over here, and okay, so now let's draw the forces. So P multiplied by cross section area, this cross section area is A, so downward force on this element will be P multiplied by A, that is due to the pressure, and that is in downward direction, and on the top of this will be P plus dP multiplied by A, that will be in up direction. Okay, and also there will be a gravitational force that will be acting in downward direction. And what will be the gravitational force on this fluid element? That will be dm into g. Okay, so before that we can calculate the dm is mass of fluid, mass of element of fluid. Okay, so that would be density multiplied by volume dV. Okay, so the density is rho, and then dV would be cross section area multiplied by thickness, so that would be rho in multiplied by A multiplied by dy, right? Okay, so the total downward force in this case would be the total downward force that will be in this direction, that will be dm is rho A multiplied by dy and multiplied by g. So now because this fluid element is static, so I can say that total upward force is equal to total downward force, or total force in y direction is 0. So total force in y direction is 0, that's why the total upward force is P plus dP multiplied by A is equal to the force downward, that is P multiplied by A plus rho A dy multiplied by g. Okay, so from here I can if I open, P multiplied A will be cancelled out, and the remaining part will be dP multiplied by A is equals to rho A g multiplied by dy. Okay, so that is the equation. Now here we can cancel out again the A in this, and so dP would be rho g multiplied by dy. Now if I want to calculate the pressure at any location, so for that I need to integrate this dP starting from taking the element from y equals to 0 till any point y. Okay, so let's say we are integrating for calculating the total pressure at any position, so that will be integration of dP, and that will be integration of rho g multiplied by dy. Now here the pressure variation is from P0, starting pressure is P0 at the top of the surface, and the pressure at any location is P, and the depth is from 0 to y. Okay, so we are getting here, so we are getting here pressure if we integrate P, so dP it would become equal to P, and P0 to P will be equals to rho g is constant multiplied by dy will become y multiplied by 0 to y. Okay, so it will become P minus P0 is equals to rho g y. So this will be a very interesting and important equation. P is equals to P0 plus rho g y. This is the absolute pressure at any point. This is absolute pressure at any depth y from the surface. And now if you want to calculate gauge pressure, so gauge pressure will be P minus atmospheric pressure, that would be rho Gy. So now here you can see this is a linear variation of pressure. Now if you want to draw the graph between the pressure and the depth, so graph would be looking something like this. This is pressure and this is depth. Okay, so at 0 depth the pressure is P naught and it is rising up like this, so the graph will be a straight line. Okay, and this would be P naught, and the slope of graph will be dp divided by dy, that would be rho g. So the slope or tan theta of this graph will be dp divided by dy, and that will be rho g. Okay, so that's it. This equation is a important equation, the linear variation of pressure with the depth. So there is a linear relation between pressure and depth. So P is equals to P naught plus rho dy. This is a equation that we are getting. Okay, so let's end over here. Now you can attempt the question of pressure variation with the depth.